Okay, so in this question we are asked to sketch a possible graph for a function. So we're given this function here, y equals f of x, and we're given a little bit of information about it, and we have to draw a sketch of it. So let me just start with a very rough sketch, and we might have to refine it later. So the information that we're given is that y is always greater than or equal to 0 for all x. We're told that dy dx is 0 when x is minus 2, 0, or 3. And we're told that dy dx is greater than 0 for two intervals, so from minus 2 to 0, and for x bigger than or equal to 3. Okay, so let's draw a little bit of a sketch here. So that's minus 1, minus 2, minus 1, 1, 2, 3, and so on. And that might be enough to work with. Okay, so the first bit of information we've got is that y is greater than or equal to 0 for all our x's. So in other words, we can forget about anything below the x-axis there. We're told that dy dx is 0 for minus 2, 0, and 3. So minus 2, we don't exactly know where these points are, but let's take a bit of a guess. Who knows? Who really knows where those are at the moment? But we know that dy dx equals 0, which means it's a local max, a local min, or a point of inflection. Okay, but what we do know is that dy dx is greater than 0 for a couple of these intervals. So between minus 2 and 0, dy dx being greater than 0 means that the graph's increasing. So we kind of have got this the right way around. We can't have this point up here because then the graph would be decreasing. So we know the graph is increasing between minus 2 and 0. It could be just a straight line, but let's say it's a curve there. We also know the graph's increasing from 3 onwards. So from here, the graph is just going upwards at some angle. We don't really know what angle. Okay, so then what happens before minus 2 and what happens in this interval here? Okay, so could this be, for at minus 2, we know that the derivative is 0, and we know it can't be a maximum because it's going up from there, but could it be a point of inflection? So could it be going like this? Well, no, it can't, because if that was the case, then this could be, actually could be, because we're not saying that these aren't the only places where the derivative is 0. So it could be that there's another turning point here. So that could be a point of inflection, but it could also be just a local minimum. So it could be something like that. Between 0 and 3, we don't know anything. We haven't been given any information. So anything could happen here. So this, let's say there's a turning point there. It could go up and down. It could be something like that. Anything like that. So we don't really know that. But we're not asked to find the perfect graph. We're just asked to find a possible graph. So if we were to sketch it out, we could have a number of different options. But why don't we just go with the simplest one, which is to say that from minus 2, minus 1, 0, 1, 2, 3, let's say the graph kind of turns at minus 2, turns at 0, turns at, and turns at 3. I guess you get the idea. So it turns like there, turns there, and turns up there. So that would be a possible graph. There could be there's an infinite number of other options, because as I said, anything could happen between 0 and 3, and we're not given any information about that. All we do know is that there's a turning point here, turning point here, turning point here. This one could be a point of inflection, but we don't really care, because the graph that we've drawn here fits all the requirements.